That light's actually flickering, it's distracting. Okay. First question here. The temperature of a cup of coffee is given by this equation. No, I'll just wait till everybody's ready to pay attention. I can sit here drinking coffee, I don't mind. No problem for me. I can happily wait until you're ready to start. I get paid either way. Right, now we'll start. The temperature, theta, of a cup of coffee is 27 plus K E minus 0.2 T. And you're told that the temperature at the beginning is 65. What's the K? So, if the temperature at the beginning is 65, then that means 65 should equal 27 plus K e power 0. T is 0 at the beginning. So that cancels, and then K would have to be 65 minus 27. What's that now? 38, is it? Okay, so we have theta is 27 plus 38 e minus 0.2 T. How long until the temperature reaches 35? So we want to figure out so that's B now. We want to figure out the time until the temperature is 35. So 35 equals 27 plus 38, yeah. So we're just looking to solve for T here. Take this over to the left. So what's that, 8, isn't it? 8 equals 38, e minus 0.2 T. Okay, so the next thing to do is to divide by 38. So the next thing, whatever 8 over 38 is, we'll get the log of it. So we can cancel the e. And then whatever the answer is on the calculator, we'll divide that answer by minus 0.2. So what did we get for T then? So to the nearest minute it would be 8 minutes, is it?
About 20 over 19, which is
20 over 19. I did something wrong. Did you use LM?
Oh no.
Dang. Right. Write that one down. We'll do number 2 now in a second. Why didn't what cancel? The 38. Why didn't it cancel? Is that what you're asking me? What do you mean by cancel? Oh, yeah. It's not that I cancelled it. I just moved it to the left. So it was up here on the right, and I moved it down underneath on the left. So I suppose if you want, it's more like that. Okay, shall we do number 2 now, or I see people writing. Number 2? Yeah. Okay. Right. A bank account grows over the course of a year. The growth is modeled by the equation B equals A E K T, where B is the bank balance and T is the time in days. At the start of the year, the balance is £100, and at the end of the year, it's £103. So at the start of the year, the balance is £100. So A ends up being 100 then. And then at the end of the year, the bank balance is £103. So 103 equals 100e, and are we measuring t in years or days? Days. Like that. Okay. So divide, and then log, cancel, and sorry, that should have been a k, and then divide by 365. So that leaves me with the k. Wait, before you come in, stop. Is your GPS off? Because if I hear it going off when you sit down, I'll kick you out. Is it off? Wait, no, don't sit down yet until you answer me. It's off? Okay, sit down then. Right, what's the K here?
8.09
-5. Yeah, okay. So, how much money will you have after a further half a year? So we want to know the bank balance now. A, E, K, T. And the T is 365 plus half. Yeah. Over 2.
Which is 100.
So what do we get? Like 105 or something? 104.5? Like this. Yeah. Okay. That's number 2. So far these are all exam type of questions. Number 3 was very similar to section B question a couple of years ago, the one we're going to do next. Got that? Number 3 now? Yeah? Yeah? Okay, number 3. Right. The town consumes 12 megawatts a day at the start of 2013 and then consumes 13 megawatts a day at the end of 2013. Model this exponentially. So what you're saying is the power of the town will equal a constant E, a constant time. And we'll use years for the time. And the power is measured in megawatts a day. So at the beginning it uses 12. So 12 equals AE0. So A is 12. Yeah?
At the start of 2013 and at the end of 2013, why are we using in days? Time?
We can. We could do this whole question in days. Did I say to use days for time? No.
But they're measuring it per day.
But
Megawatt per
not
day.
it isn't supposed to be exponential and days instead.
No, it's perfectly fine to use days or years here. Now I understand why you want to use days because it's the unit is per day, isn't it?
Yeah.
So if you prefer to use days, that's fine.
No, but if you use years,
Yeah.
how are you going to calculate at the end of 2013? What month today?
1 year.
1 year.
No. Oh, okay.
Yeah, just divide by 360.
Yeah. Yeah. No, it's fair enough. Like maybe you want to use days, it makes more sense. You'll get the same answers though. Well, that's not true. You'll get different constants, but all the values you calculate will be the same. So when you calculate the power in a year's time, it'll be the same. Anyway, well, I want to keep it the same to what most students did. Did most people use days or years? What was it? Years. Couple of, okay, I'll use years. Right, so at the end of the year, that's 13. 12E 1T. See, the reason I like using years here is because the T then is 1T, so that's a B, because the T is 1. That's why I want to use years, because it makes it a little bit easier. Because I'll do divide by 12, get the log, and then there's no need to divide by 1. So it's just log 13 over 12 is the B, which is, what's that please? 0.034. No? That seems a little bit small.
0.08.
Uh-oh. 0.08?
Yeah, 0.08.
Exact?
Yeah, 0, 0.
Okay, oh, yeah, okay, go on. So now you have the power will equal 12e 0.08 t. Like this. Yeah, that's part A. So now we'll go on to part B now. So in part B, I ask you to do the same thing, except assume a linear relationship.
What time is that?
This one, we're at 10, nearly 11 minute mark. Okay, scroll down. Yep. So in the next example, I want you to assume it's linear. So that means the power will equal a constant plus a constant t. So again, at the beginning it's 12. So 12 equals a plus b times 0. So again, a is 12. And then 1 year later, 13 equals a plus b times 1 again. But actually we know that the a is 12. So then the b must equal 1. So we get power equals 12 plus t. And that's the answer for part B. Question? What? You don't seem happy. What? Okay. So, in part C, I ask you to use your two equations to make a prediction for how much energy the town will use in 2 years' time. So that means, let's have a look here. So if you use the exponential, p equals 12e 0.08t, or p equals 12 plus t. This one says the power should be 12e t is 2, so that's 0.16. And this one here is p will be 12 plus 2. So this one says the power will be 14 megawatts a day. And then what's this one here? 14, so 14.1 then, megawatts a day. Yeah. Okay. Which do you think is more accurate? Yeah. Oh, I wouldn't say it's obvious. I wouldn't say it's obvious. Which one do we think? Yeah. Why though? Why are we thinking exponential? No. We keep hearing this word exact means decimal. No. This is exact. In fact, this is exact. This is not exact. Yeah, but you don't know that. No. That's not a good enough reason. No. Something else.
The gap between every year increasing is not the same, so it's not linear.
But how do you know it's not linear?
The gap between every year is decreasing.
Yeah, but how do you know that?
What is exponential?
So anyways, look, I'll tell you, the reason is, when you look at things that grow, especially like cities, populations, they tend to grow exponentially, up until some limit. Guys, I'm talking here. So when you look at populations or cities or whatever, they tend to grow exponentially up until they reach a limit. The problem is you don't know if this city is a small city getting bigger or a big city kind of leveling off. So you can't actually be sure if it's exponential or linear, you know. So like for example, if it was a city like Dublin, I expect perhaps it'd be more linear. Whereas if it was a smaller city that was growing, I don't know, some city that just popped up in the desert one night and just started growing very quickly, they discovered oil or something. Exponential perhaps then. Okay? Yeah.
So
Like if I look at Saudi Arabia over the last few decades, you know, it went from tents to skyscrapers. So that would be exponential energy consumption, right? Yeah. So it depends on the city.
We can only use common sense to solve this.
Yeah. Yeah. By the way, in the exam, the question might be, Jed. In the exam, they might finish the question with 1 mark by asking you, it doesn't matter if it's exponential or linear, they might say, do you think this model will hold for a long time in the future? And the answer is always no, because exponential or linear, it can't increase without limits. It doesn't matter. It doesn't matter if it's exponential or linear. It has to start leveling at some point. Okay. So the most accurate model is probably going to be that one you did in biology, the logit, or what did you call it in biology?
Exam activity, substrate control.
Yeah, no, but you had a name for the shape. What did you call it in biology?
Shape, Japanese shape.
S-shape? No.
Heavy
That's better, wasn't it? Yes, we call that logit. Yeah, but it is probably that. Okay, number 4 now. Can I scroll down? Yeah. Okay, number 4. Anne invests in a financial product that yields 12% APR converted monthly. This means the bank pays out 1% interest per month. How long until she doubles her money? So, because the interest is paid monthly, it'd be appropriate to use months as the time. Now, I didn't say this in the question, although I kind of suggested it in number 2. When you're looking at money in a bank, we talked about this, it's usually going to look, your money's going to look exponential. It's just, remember we said you die before you see it take off, is the problem. However, maybe not in this example, because the bank is actually paying a lot of interest. 1% per month is an extreme amount of interest to be paying out. So, at the beginning, we don't know how much money she has, because I don't say in the question. So we'll just say at the beginning she has M0 at the beginning. Okay? So that means M will equal B, M0 will equal BE0. So the B is M0. In question 2, it was £100. So we have M equals M0 E K. Not K, sorry, I'm using the letter A in this one. Oh yeah, it's B and A, doesn't matter. A, T. Now, we have a little problem. We need to figure out another point to sub in. So, we're told that in a month's time, she'll have 1% more. So, when the T is 1, what will her money be? What is 1% more of M0? She started off with M0, and now she'll have 1% more of M0. Yeah, it's 1.01 M0, because you added on of 100 of M0. You added on 100 of M0, so it can't be 0.01 M0, because that means you would have less. You know, it has to be an addition to her balance. So we have 1.10 M0 equals M0 E1A. Now, it didn't actually matter that we don't know the M0, because what will happen to it? Cancel out. And then log, gone. So the A is whatever log 1.01 is. What's that, please? Okay, so I'll just say 0.01. Okay. So we have her money will equal the money at the start, e power 0.01 t. T is the number of months. Right, what do we want her money to be? We want it to double. So what are we going to sub in for M now? 2M0, good.
How did you get that now?
Okay, so next, divide, and then next, log, then next,
I thought you said log.
divide by 0.001, So in the end you'll get t is roughly 70 months. 60 months is 5 years, so it's 5 years, 10 months. Roughly, isn't it? Yeah.
Sir, is it okay to round up like twice like that? Always?
I know, I'm being lazy because I don't have a calculator, so.
Yeah, so if we're doing it in an example.
This way I have to write one less digit.
Yeah.
I'm tired and hungry, you know.
Yeah, no,
But in the exam, more decimals is better. Yeah, more decimal places. So that is roughly 5 years and 10 months. Not so bad.
What means by 12% APR converts to monthly?
Yeah?
What does that mean?
Oh, that means 1% a month. You take the 12 and you divide it by 12. So for example, if it was, let's say it was 24% converted monthly, that means it's 2% a month. It's just it's just a business term. It's not a maths term, it's a business term. I'm sure you've seen this on ads for banks, you know, something like 6% APR. Yeah. So APR just means the amount per year. But it doesn't mean that they pay you once per year. Because in the small print, like there'll be a little bit star, it'll say something like paid per whatever. And some banks pay every month. Some banks pay every 3 months. Some banks pay every 6 months. So, you know, the way you say that is you would say converted monthly or quarterly. What would be every 6 months? What's the word for that?
Bi-yearly.
Bi-yearly?
Yeah, they do that.
Okay, what's the other word for it? Yeah, I don't like it. Because it's always confusing if you mean every half a year or every 2 years. So, is there another word that could mean more clearly half a year? Every half yearly? Another. It's like this, another prefix.
Twice annually?
Twice annually is okay. What about semi-annually? Semi-annually? Yeah, every half a year? Yeah? Yeah? What do you think?
You use bi-weekly for every 2 weeks, so I can use bi-yearly.
No, nobody says bi-weekly here. Nobody says that.
Where we come
He's
from.
not Irish.
He's from Dubai. We use it in Dubai.
And Dubai culturally is very similar to Ireland. Yeah.
That's better business.
What's the word here for every 2 weeks? You should know this. That's fortnightly. Yeah.
What? Okay.
Fortnightly? Okay. You don't know this word? Most people say every fortnight. Yeah. I think you could say it, but like if you were looking on a magazine or a newspaper or something, it would say released every fortnight. Yeah. Okay, number 5 now. Loudness is measured in bells, where bells is log base 10 I over I0. And I0 is a constant, and I give you the value of I0, it's 10 to the minus 12. I'm not sure actually, I'm not sure. Is it? Is it 1L? I'll have to double check that, yeah. If a fired gun measures 13.4 bells, then what is the sound intensity from firing? So here it's not actually difficult. I tell you what the B is and I want the I. So the B is 13.4 and I want the I. Okay, so what, not log here, sorry. What should I do here to get the I, do you think? Is there any easy way to cancel log base 10? No. How do you cancel log base 10? No. Log, no. You know that's wrong. You know it's wrong when it came out of your mouth, not log. What?
No.
Yeah. 10 to the power. 10 to the power. So 10 to the power of 13.4 equals I over 10 minus 12. Because remember what you're saying here. You're saying 10 to the power of 13.4 is equal to this. Yeah. So then you get I is 10 to the 13.4 times 10 to the minus 12, which is Uh-huh.
You put 14.
Did I? 13. Oh, sorry, thank you. 13.4. Minus 12, so that's 10 to the 1.4. What's that? Like 11? 11 and a half? What is it? Yeah, what you got up here?
25.11.
25, that big?
25.11.8.
Yeah.
25.11?
11.88.
Yeah.
So 25.1. Yeah, okay. Right, okay. Number 6 now. Number 6 is a bit harder. Can I scroll down?
And the answers you wrote only 25.
Did I?
Yeah.
Did I say anything about rounding off? No. Okay, I should really have 25.1, yeah? Okay. 6. As an example, the radioactive decay of carbon-14 is exponential with a half-life of 5,730 years. A quantity of carbon-14 will decay to half its original amount after about 6,000 years, regardless of how big or small the original quantity was. After another 6,000 years, 1/4 will remain, and so on. So what's happening here? You might have heard of this before in biology. You have this thing called carbon-14. Everything that's living contains carbon-14. Yeah, and when it dies, the carbon-14 decays. So imagine something had 1 gram of carbon-14 and it dies. It means in about 6,000 years, in its remains, there will be half a gram. And then in another 6,000 years, there will be 1/4 of a gram, and so on and so on. Okay? So it's a useful thing to know because it means that if you measure how much carbon is in something, carbon-14, you can actually work out how long ago it died. And that actually is how you can date ancient documents, because ancient documents were made from trees. So you would imagine when the tree was cut down to make the page, that there wasn't much time between cutting the tree down and actually making the book. So you can be, it's not like they cut the tree down, waited 100 years and then wrote stuff on the page. So you can accurately date how old books and documents are using this technique. So the example I have here, the Dead Sea Scrolls were found to have 79.5% of their carbon-14 remaining. How old are the scrolls? Okay, so we will have the formula, we'll say the amount of carbon is equal to AEBT. So we know at the beginning there's always 100% of the carbon-14 present. So we can say 100% will equal AE0. So okay, we have our A. Now we're also told 5,730 years later there will be half the carbon-14. So we know that 50% will equal 100% E5730T. So we'll divide. We get 0.5 equals E5730T. Log, cancel, divide, and we have. Oh, sorry. Sorry. Yeah, it's B. It's B. And we have our B. Oh, flip B. Thank you. Okay. The B is going to be a pretty small number. What do we get for B?
I'm pretty sure this is not correct.
No, it's going to be very small.
It's minus 9.3. I would highly doubt.
No, it's minus.
Minus
1 point. That seems
No.
a bit too big. Oh, did you divide by 5730? After the log? Like, do log, get the answer, and then divide?
By the way, do you mean log or lim? Because you're using them interchangeably.
Log. I talked about this in class.
It's
What is it?
minus 1.2.
Minus 1.20
Yeah.
1 into 10 to the negative 4.
Yeah.
2 1.
2-1. You got the same?
Well, 0.9. So.
Yeah, okay. Yeah? So now we have the formula carbon 14 will equal 100% E minus 0.000121 T. So now we can answer the question, how old are they? Well, they have 79.5% of their carbon left. So 79.5% equals 100% E minus 0.000121 T. So you get 0.795 equals E minus 0.000121 T. Log cancels that. And then divide by that. Cancel. So roughly, two significant figures. What do we get?
Can we put
1895.
minus 1.1
Yeah, of course, yeah. What do we get here?
1895.
Yeah, so two significant figures. What would that be? 1900?
190.
Yeah, 1900 years. Yeah. Okay.
What time is it?
This one's at 31. Okay, do you write that down? Yeah. Can I scroll down? Yes? Okay then. The reason... Are we listening? We're listening? So, the reason I put this one in here is because one problem with the carbon-14 dating is there's a little bit of an error. So it's not going to be exactly 900 years. I think these things have an error of plus or minus 100 years. Something like this. So this is a famous example of carbon-14 dating because at the time it was really important to know how old they were, because 1900 years ago would make it 100 AD. And some people were wondering if they were older or younger than 35 AD, roughly. So you realize because of the plus or minus 100, you can say, well, it might be or it might not be. Problem. Right, okay. Number 7 now. A teacher's playing a warm-up game with his students. He thinks of a word in the dictionary and the student wins when they've guessed what word he is thinking of. If they guess wrongly, the teacher will say if the word they guessed comes before or after his word. For example, if he's thinking of cat and then the student says bat, he will say no, but my word comes after bat in the dictionary. So this game here, you ask what the word is, and you're either told the real word is before or after this in the dictionary. So if I'm thinking of dog and you say apple, I'd say it's not apple, it comes after apple. So then you say, oh, okay, monkey, and I say no, it's not monkey, it comes before monkey. And in this way, you kind of narrow in on it. Yeah. Now you might think it will take a long time to figure out the word. It actually doesn't. There's a maximum number of turns it will take before you figure out the word, which seems a bit strange because you imagine you're only allowed to ask, is it this or is it not? And the answer is yes or no, and I say it's before or after. But what ends up happening is you kind of zoom in on the word. So you kind of say, oh right, well if it's before monkey, then it can't be anything here, and if it's after apple, then it's here, and you kind of zoom in on the word. So we want to know how many turns could it take. And the piece of information I gave you is assume that there's 16,000 possible words. Okay? Alright, so let's have a look here. So you start off with 16,000 words. Now, after the student makes their first guess, how many words are left that could possibly be the answer? No. 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 So, I'm thinking of a word, and you ask me, is it monkey?
Oh, the one without the...
-1.
No, not -1. No, it's much better than -1.
-1,000.
Much better than -1,000.
The whole nonsense thing before...
Yeah, which is going to be how big? After or before, whatever the situation is. So how big?
Twice.
You're not getting this. Okay, hang on. Listen. So, we'll try this out. I'm thinking of a word. I want people to ask me, is it this? And I want you to listen to what I say. Okay? So, let's see. I'll think of... okay, I got something. Right, Michelle, ask me what word it could be. Think about any word it could be. Bread, it is not this, it is after bread in the dictionary. Okay. Ask me one.
Is it table?
It's before table. Now you see, only after 2, you know that it's somewhere between B and T. Yeah? So think about it. What is the best word to ask someone at the beginning? It should begin with what letter? No. The middle, yeah, because if you ask somebody a word beginning with M, you either know it's either before or after M, you can cut your supply in half. So if you choose a middle word of what you have, you can half the possibilities each time. So the 16, after one guess, you can go down to 8,000. You see, and then after another guess,
It's just a half life.
yeah. This is after 2 guesses. Okay, so if you were to model this as an equation, it's exponential. Do you need to talk to them, or are you just looking for one person? Or are you passing through?
I want to check with you, see if those who are due to depart have departed. Couple of students
Oh!
to go to see
Oh yeah, very good. Okay. No, nobody's left yet.
Okay.
2 people need to? 2
Yeah,
people need to.
I think a couple of people to the head over the way. Zara, you're going to go over. And Afrina, did I email you? I didn't? No. Okay, cool. So Zara, going to head over there for them. Did you get my email?
I'll give you guys a minute to try and figure out the constants here, okay? The formula is... No, it's okay. It's going to be A, E, B, T. I want you to figure out the A and the B. I think you can do this.
So you assume every time try. Just like half decay.
Yeah, if he's smart about his words. Come on, guys! I want you getting the A and the B, not chit chatting. Anna, no chit chatting. I want the A and the B, please. The 2 of them. You want to talk to her outside, because she was eager for it. So okay.
Isn't this exactly like the question?
Yeah, that's why I think you can do it. So give it a try.
Oh, I thought there's some type of code.
Mubarak, work, please. Right, you should have the A at least by now. What's the A? No, 8,000. If you make one guess, how many words are left? 8,000. When the t is 1, you have 8,000. Oh, sorry, I'm sorry, my apologies. Sorry. When the t is 0, you still have 16,000. Yeah. So you have G equals 16,000 E BT. Now, when you make one guess, you have 18,000. So you have 18,000 equals 16,000 E B. Yeah, okay. So it's going to be log 0.5 will equal B, which is 0.69. Yeah?
The T is not changing.
What?
T is not changing.
T is changing. Minus. Yeah. Go ahead, Jeff.
One thing is with checking when we were to 8,000, 6,000 would be B.
Yeah, the T is 1.
Yeah.
Yeah. This isn't going to be a thing where you're still confused that 0 and 1 are different numbers. I thought we cleared this up. You understand that they're different, don't you? 0 and 1 not equal. Okay. So, we have G equals 16,000 E minus 0.69. I wrote T. And I wrote G here. Oh, that was a stupid choice of letters. Sorry. What would be a smarter choice? W. Why did I pick W? Words. 16,000 E. And what letter maybe should I use up here? G. Or maybe even N for number of guesses. Yeah. Now it makes sense. Right. Okay. So I want to figure out how many guesses I need. So, what is the W going to be?
1.
Good, 1. Because you want to keep making guesses until there's only one word left. So, W is 1. Let's solve this. Log. Right, what do you got here? What do we got here?
Minus 7.5.
Now, it's very important now is it rounded?
So 14 words.
Is there something after the decimal on the 14? It's not exactly 14. Yeah, so listen, again, we're in the situation where we have to think carefully. Yeah. Listen to me. So we're in the situation we were in the last chapter. We have to think carefully about which way to round. So it's 14 point whatever, 1 we'll say. Do we round up or do we round down? Oh. Yeah, because you can't make 14.1 of a guess. So it only makes sense if you made 15 guesses. Yeah, so 15. So is the answer 15? Jed, you're driving me nuts now. Can you listen to me, please? Are you listening? Thank you.
No, the answer is 14.
Is it?
Because it's 14.03.
14 point. Well, I suppose the problem is I rounded a little bit here, didn't I? It's not exact. If you were to type this in on the calculator, can you tell me what you get? That minus 0.69 was log a half. So if you type this in, we'll be more exact. What do we get? 13.9. Okay, so now the 14 makes more sense.
So this is optimal condition in this question.
Correct, yeah.
Because every try you say just cross out a half of word.
Yeah. Now, if the person had a dictionary, it's possible to do this, you know? So, like, you could actually, if you had a dictionary, get the middle word every time. You're right, it's optimum.
What's your time?
So what was the word you were thinking about?
Maybe we can do it if you like.
Was it
As
loud?
as young as Young Peng pointed out, in course 14 is optimum. It could actually take more than 14. How many attempts could it take? It could take as many as 16,000 attempts. How could it take 16,000? That's if the person goes one by one, starting at the first word, and you were thinking of the last word. That really is the worst case, isn't it? So worst case is 16,000. What is the best case? 1. Well, yeah, if you're very lucky, it's 1. So this 14 is what you might call the computer case, where if a computer was doing it optimally, it should only take 14 attempts. Okay, so obviously this would be great, this would be a disaster, and this is really what we're thinking it should take. So if I was doing this with students, it should take a little, sometimes maybe less than 14, sometimes more than 14. Yeah. Right, let's try it. We'll finish off by trying and see, okay? I'll start at this side of the room going across. Right, okay. Hang on. I'm thinking of a word. You have to listen to everyone's answer, right? I've got a word. Go, Young Payne, ask me.
Hemoglobin?
I wasn't thinking of hemoglobin. It is before hemoglobin. Before hemoglobin. Right. Go.
Moose.
Say again?
Moose.
Spell that?
M-O-O-S-E.
Ah, no, you see, he made a bad one because I said it was before hemoglobin.
Okay.
So you know it can't be any, yeah, okay, so I'll let you try again. Give me another word.
Bat.
It's after bat. After bat. And before hemoglobin. Hang on, I'm thinking. It is before cat. Oh, now it's really narrowing down now, yeah. So we have it's after bat and before cat. What do you think? After bat and before cat.
Yeah, so the second letter.
Yeah, now you have to start thinking about the second letter. Yes, it's after bat and before cat. Yeah. There are many words in the dictionary between bat and cat. It doesn't skip.
Binomial theory.
It's not your turn. Is this your guess? Binomial theorem? It's after binomial theorem. It's after binomial. Any of you? You had your guess now. Want to make brunch? Let's see. It's after brunch. It's after bus. It's after bus and before cat.
Think about a word to see.
Okay, calculator. Let's see now. It is before calculator. It's before calculator and after bus. No. That's too similar to calculator. It's before calculus as well. Before calculator, after bus. Let's see. After but. Yeah, it's likely, isn't it? What are we at? We're at about 10 guesses now, is it? Nearly 10 maybe? So you should be getting close to it. Buzz. After buzz. Now you see, come on, you're getting... It's quite clearly a C word, I think. It's okay. We're good.
All C words before L. P-A, car, no, it can't be car, it has to be before town. It has to be before L. It has to be before L.
What's our next guess? Can.
It has to be before L. Before L.
Yes, you're right, yes. Before this one.
Cab?
And after T.
It's after cab. It's after cab and before cal. Come on, we're really narrowing now. No. Cake, correct. You got it, yes. Very good. Yeah.
The worst case must larger than 16,000 because if you pick some words the teacher don't know.
Oh yeah, well I said assume there's 16,000 words that's common to everybody. Yeah. Yeah, I even knew hemoglobin though, so that's it. So you can see it was about 14 guesses I think, and all the words in the English language you managed to get down to the one I was thinking of. Yeah. Okay, we'll leave it there. So I'll see. The extra. Don't you have another class now? No. It's like a GP. Yeah. Thanks.